Good afternoon, everyone. Welcome to this webinar for DSLAB, and we are going to give a brief demo for the list of features and enhancement that we have released for 7.6 release of the product. This is briefly the high-level roadmap that we had envisioned from 7.5 release, which was the previous release. So we had intended to come up with AutoML within DSLAB. We had also planned to include data preparation and integrate it with DSLAB. Pytorch model inferencing for ML models in pipeline. This was also something that we wanted to do and accomplish in 7.6. Data catalog integration with DSLAB was also something that we wanted to achieve, and we have done that. We also wanted to provide kernel session manager in notebook, and with this ability now we are able to stop the kernel, and we are again able to restart the kernel as well. We also have provided the ability for merge and split cells. This was also in the previous roadmap. We have also provided the static updation of lists. So this is something that I will show you what is meant by this. We have provided the feature of creating a copy or saving as of a notebook. So if we already have an existing version of a notebook, we are giving the user an option to create another version. Then we have the preview option for artifacts and datasets. So this has also been achieved. And we are also providing option to add datasets or data sandbox files from inside the notebook. So previously we used to add the datasets or data sandbox files by going to the datasets option. But now we are providing this option from inside the notebook also, so that the user does not have to navigate outside and go to the datasets tab, which was an inconvenience, and we have removed that hurdle. We also have provided Variable Explorer. Now, Variable Explorer is something which is very cool for people who are working as data science professionals, and they many a time struggle and use print statements to find the value of the variables and keep track of how many variables they have created. So we have come up with a Variable Explorer option also. So I am just going to briefly talk about this AutoML feature that we have included. So in what is AutoML? So to begin with, AutoML is nothing but automated machine learning, which is the process of automating tasks that apply machine learning to real world problems. AutoML is actually capable of covering all the steps in the machine learning lifecycle, starting from a raw data set to creating a ready to go machine learning model. And we several times in the ML community, we come across a jargon known as AutoML experiment. So what is an AutoML experiment? An AutoML experiment is the application of machine learning algorithms to a data set. So here, for example, you can see in this GIF, uh, you can see in this GIF, I start from the dataset tab and I click on create experiment. So when I click on create experiment, it takes me to this screen. So create experiment is nothing but this will create a set of or apply a set of machine learning algorithms to this data set for its analysis. Now, once we have given the name of the experiment and its description and chosen the target column, we can go for either the classification or regression, because these are two commonly used techniques for dealing with supervised learning problems. Now, what is a classification experiment? A classification experiment can be created for discrete data, whereas a regression experiment can be created for continuous data. Now, we also have the ability to create both classification and regression experiments simultaneously. So in this GIF, you had seen that I had created one classification experiment. And if I want, I can simultaneously create a regression experiment as well. So what will happen is once the experiment is completed, I can go and view the report. So you can see that it shows the recommended model, which is the best model that has worked out for this data set. And we are listing the top three models out here. We can click on the explanation, and this will give us a summary for the overall performance of the model. For example, we can give the individual explanation using ice plots, then partial dependence plots. We also give the model performance using confusion matrix and performance metrics. And we also mention the feature importance, the features that were used or the features that contributed towards the prediction of the accuracy. And then we are also giving dataset explainer. Dataset explainer is nothing but it gives you a complete overview of the dataset that has been used. So it is just like pandas profiling, and it gives information about the number of variables, number of columns, the missing values, and the data types, and all of these information related to statistics for a particular data set. All of that is available. So in short, what AutoML gives me uh, is the ability to take away the complexity of working with notebooks, which can only be done by data science professionals. So even if a person is not a data science professional, but he intends to analyze a particular data set and find the prediction in case of classification or regression and come up with some metrics, then he is most welcome to use this feature and just upload the data set, choose the predicted column, and then go ahead and sit back and wait for some time for the experimentation to complete, and then the results will be in front for the individual to analyze and take the next steps. So this is a brief summary about AutoML, and we move on to the next slide. So the next slide takes us to data catalog. So data catalog is a feature that is already existing in the BDB platform. Now, what we have done is we have integrated data catalog with DSLAB. For example, when you come to a particular project and you activate the project, so this project name is Project Data Catalog. Now, when I go to use the catalog service using AI search, and I search for the project name, which was Project Data Catalog, I type that name, I hit enter, and I get information about the project data catalog and all the elements associated with that project. So the project, as you know from the previous webinars that we had discussed, consists of several elements. Vis-a-vis, it has notebooks, it has models, it has artifacts, it has data sets, and it has utility scripts. So many different elements are there. So data catalog gives me a graphical pictorial representation of all the different elements that are associated with a particular project. So this is a very cool feature that enables a user to get a complete overview of the project that he is working with and what are the different elements that are associated with this project. So this is something which is very interesting. Then I had talked about data preparation in the high level roadmap from 7.5. So we wanted to include data preparation within DSLAB. So data preparation is also an already existing feature of BDB platform, but we wanted to integrate this with our DSLAB so that it helps the data science professionals to actually do a lot of transformation that they do, using code. That can be done by using user interface and just click of certain buttons. So this is also something that is very intuitive, and it's not just dependent on what the user is doing as far as coding effort is concerned. So it helps the user to see what kind of columns he is trying to transform and what is the result that he is getting out of transformation by just clicking certain buttons. For example, I go to a data set here, which is fashion retail, and I click on data preparation. Now, when I have clicked on data preparation, I select a particular column, say branch, and I want to transform this column by changing all the characters of this column to uppercase. And I click on create new column, which actually gives me a new column branch underscore uppercase underscore one. You can see all the entries are now in uppercase. So I save this data preparation step, and then I go to uh, the notebook from where I had initiated this data prep step, and I click on the fashion retail data set, and I click on data preparation, and I select the preparation step that I had created. Then I click on generate preparation, and you can see that an ID gets attached to the nb.get underscore data. And once I use this command, the data frame gets generated with the new column, which has the branch in uppercase. So this is how easy it is to use data preparation and change the data set or data sandbox files that we are working with. And this also gives us a visual inspection ability, which is very handy and which is very intuitive and which also helps people from creating less mistakes and less iteration when they are doing experimentation by creating data science notebooks. We have also included Pytorch ML inferencing in pipeline. So you can see this is a Pytorch notebook, Pytorch machine learning notebook to be more precise. And we have just actually created a classification experiment here. We are trying to predict a column, whether it belongs to a particular category or not. And then we are trying to save the model here with the name PyTorch model underscore v1. Now, this model is of model type ML, which is machine learning. So once the model is saved, it will be listed under unregistered list of models, which is what we can see here. And then we can register this model such that it is now going to be available in pipeline. So in pipeline, we already have a pipeline created PyTorch model inferencing. And in this PyTorch model inferencing, I would be referring to the DSLAB runner component from which I would be checking the project which contains this model file. So once I have selected the model file and I have selected the type as model runner, I'll just invoke the pipeline. And the first component, which is highlighted in the red as RDBMS, it is nothing but the component which actually reads the data from MySQL database that contains my test data on which I want to run inference. So that test data will be picked up from MySQL DB, and you can see these are the logs for that. It is reading the data from MySQL DB, and then once it does read the data, it will run the inference model on top of that. And once the inference model is run on top of that, it is going to serve us the predictions, whether it belongs to class 1, class 2, class 3, whatever be our use case definition. So once we keep on refreshing the logs, you can see that the data is sent to the output event for the second component. And then we can see that the prediction column is already generated now. So we can see the different predicted values. So this is how seamless the transition has become from creating a model in data science lab notebook to productionizing the model and creating an inference pipeline in the pipeline uh, module. I had also mentioned about including kernel session manager. So as you can see, we have included kernel session manager to shut down the kernel. So this icon here, if you click on it in the notebook, it will shut down the kernel and it will give a message kernel is stopped. And we have also given a user a button feature pressing which we would again be restarting the kernel and we get a message that kernel is restarted. So this is a feature which is very important because many a times data science professionals when they are working with many different uh, tools, for example, Jupyter or Google Colab, these features are indispensable. Uh, these are required at times to shut down the kernel to save the resources, or if there happens to be a case when the process is going into an infinite loop because of incorrect coding practices, then also in order to save the kernel resources, we shut it down and then we try to correct the situation which is causing infinite loop, and then again we restart the kernel and resume the experimentation process. So this is something which is very important and it saves people time while they are debugging the issues when creating experimentation with DSLAB notebook. We have also included ellipsis button. So I have not included this from the roadmap, but these are certain enhancements that we have included. So previously we used to have these uh, transform, save model, predict, save artifact buttons listed down the cell. So now we have included all of them under the ellipsis. So it gives us a less cluttered view of the notebook cell, which allows the user to concentrate on the code that he or she is writing. And it gives them a very beautiful, interface with any of these buttons that they can use by just clicking on the ellipsis and clicking on the button. So this takes out the clutter and eases the space and gives a very clear view to the user as far as the code that the user is writing and also as far as the output that the user expects to see out of the code. Then we have also enabled the merge cell and split cell option. For example, if we click on these two cells, uh, the first cell import pandas and the second cell, and we just click on Control Shift M, then these two cells will get merged together. And if you want these two cells which are already merged, if you want to split them, then we can click on Control Shift Dash. Once we do that, then these cells will be separated. This is also a very cool feature which saves us extra steps of selecting, cutting, copying, pasting, and then deleting the cell. So with just a click of certain buttons, keyboard buttons, we can just merge cells and we can split cells as well. We have also included timestamp for notebooks and model lists. So this is also something that is an enhancement, and now it gives us the date and the time as well about when the notebook was last modified. And as I have mentioned, we have enabled the save as feature so that if you have a notebook with version 1, you can save a copy of that notebook with version 2 or any other name. So now the your project will contain two versions of the same notebook. So this feature is also enabled now. Another important feature that we wanted to include, and this takes out a lot of inconvenience that data science professionals might face several times. And those who are familiar with the usage of tools like Google Collaboratory or Jupyter might be familiar with this. Whenever we are in the notebook space, so this is the notebook space. So in the notebook space, a user should always have the ability to add dataset or the file input file that the user wants to process in the experimentation. So previously what we were doing, we were coming from the dataset root and we were adding all the datasets there, ensuring that whatever datasets we want are already listed in our datasets tab. So right now what we have done is, even if the user forgets to add a particular dataset in the dataset tab, the user can always come to the notebook and click on the dataset option and click on add button. So once the user clicks on the add button, then the user is able to either choose from data sandbox or choose from dataset. So as you can see, the user clicks on the add button and he can use either datasets or data sandbox files, and whatever input file name he wants, he can select with the help of a checkbox, and then he can click add. Once he has clicked add, that dataset is now available, and once you just click it, that will be available to be transformed into a data frame and to be used in our experimentation. So this is a very important feature, indispensable, I must say, and I am quite pleased that it is now available in DSLAB. Another important update is the static updation of lists. Now, previously, for those who have been keeping a keen eye on the development, whenever we used to activate or deactivate a project, it used to take up the entire screen, and the loader used to load and all the contents of the screen would be lost. So we have removed that, and now whenever we are activating or deactivating, this loader only moves in the cell where it is clicked. And also when we are saving a notebook, the entire content of the notebook is not lost. So this is another important thing which gives a very good user experience to anyone using these features, because when I save a notebook, I don't want my content to be lost, and I also want to see the message that my notebook is saved. So this is also something that we have enabled in this release, and it is something that removes the inconvenience of not being able to see the list of projects or the content of the notebook when I have either clicked on activate deactivate project or I have clicked on save notebook. So this is related to the preview option for artifacts. So as you can see, we have included preview option for JSON. So here you can preview JSON artifact. We can also preview CSV files and see the data and the columns there. We can also preview plots. We can see the plots. We can also preview text files, and we can see the content of the text file. So this is also a very cool feature that has been enabled, and this gives a visual inspection immediately to the data science professional to just make sure that the artifacts which have been generated out of the DSLAB notebook experimentation process look good before proceeding ahead. So we also have the preview option for datasets. So if you click on any dataset, for example, if I click on say housing dataset and I click on preview, I would be able to see the different columns and some of the values that are there. So this is also something which is very intuitive, and it saves me the time to do coding by typing the first two cells here. So if you can see the first two cells that I have coded over here, if I just go back, if you see, I have coded import pandas first cell, and then I'm reading the data into a data frame, and then I'm able to get the uh, data frame. But if I want to avoid this and I just want to preview the data set, I'll click on the preview option and I'll get to see the data set. So this gives me sometimes, the flexibility to decide whether this is the correct version of the data set that I'm using or not, rather than writing some commands and seeing the output in the output cell and then realizing that, oh, this was a mistake that I did. I am referring to the wrong version of the data set. So preview option of dataset actually helps me, save some steps before I start my experimentation and just be sure that I'm using the right dataset. Now this is the option of variable explorer, and you can see whatever variable we are creating in our notebook, all of those are getting listed here. Even if that variable happens to be an object which is NB, which is nothing but the object of the notebook class, notebook executor class. So even that is being listed, and then the data frame is being listed. Whatever variables we create, all of those variables will be listed inside the variable explorer tab, which has the name, which has the type, which has the shape, and which has the value. So this is again a very interesting feature which enables the data science professionals to keep a tab. So we can see this. We are previewing the variable value here of the data frame, and it gives us an option, especially to the data science professionals, to keep track of all the variables that they have generated in a particular notebook, because many times a person loses track of what all variables they have created, and they might go ahead and create more new variables, whereas they could have made use of some of the existing ones already. So with that, I come to the conclusion of this PPT presentation, but I would just probably like to show you uh, some of the things that we had already discussed here in the PPT. For example, if I go to an already activated project, so if I want to start an AutoML experiment, I'll just go to dataset and I'll choose a dataset and I'll click on create experiment. So once I have clicked on create experiment, I can just give it any name and I can give a description, uh, adult income prediction, and I can choose a target column. I can choose a target column as income, and I can give click on next, and then I can click on classification because this is a classification problem. Then I can click on done. So once I have done this, so this experimentation will run, and as you can see, these are several experimentations that we have already completed, which were run previously. So as I already informed that an experimentation is nothing but the application of machine learning algorithms to a data set. So you can see that this is one of the completed experiments that we had run for adult data set. It has about 50,000 rows, and this is the best model that was generated out of this experimentation. And this is the recommended model based upon the best score for the accuracy metric. So I can see that the run summary gives me that this task type is classification and the primary metric for measurement is accuracy. And who is the person who actually created this experimentation and when it was created. Then I can go to the models tab, and in the models tab, I can see that the top three models are listed, and I have the option of actually scrolling and checking the explanation further to try and analyze the model more deeply. So if I want to see more information related to the best model, I can just go here, click on view explanation, and I will be taken to the model summary page, which tells me that the best algorithm for this experiment was XGBoost classifier. And if I click on individual explanation, then it gives me Shapley plots the features which actually contributed towards the negative and the positive class prediction. And then it gives me ICE plot, individual conditional expectation plot. So what it does is it gives me the ICE plot for the top two features. Top two features in the sense when I go and click on feature importance, now you can see that these are the features that actually contributed to the prediction of values for this particular data set, whatever predictions we are getting and whatever accuracy score we measure based upon those predictions. So these features are the ones that have contributed mostly towards that prediction. So if I go to this tab again, so you can see relationship and occupation are the top two features. So relationship and occupation. This is a top feature. This is the feature on the second rank. So when I go here in the ICE plot, I can see there are two plots here related to relationship and occupation and how these values change pertaining to the target column, which was income. And then we have the partial dependency plot also. These plots are also created for the top two features only by default, which is again relationship and occupation. And we also give the model performance. And model performance is something which gives us the confusion matrix plot. It gives us performance metrics, and it also gives us precision, recall, F1 score, all of these different values, which are very important in case of those experiments where the accuracy score in itself is not uh, a desirable metric to decide whether to go ahead with the model or not. For example, if I am working in a field of a hospital, prediction or prediction of cases related to medical issues like diabetes or cancer, then obviously predicting cancer for patients will always give me a higher value because there is a very less percentage of people who actually get cancer and they die because of that. So we need certain more metrics to help us in order to understand whether this algorithm is the one which is suitable for this use case or not. So those metrics are nothing but precision, recall, and F1 score. So that is why we are giving an option to the user that if the use case for which the user is running this experimentation is something where the accuracy score in itself is not uh, you know something upon which it can be decided, it is not enough. Just by accuracy score we cannot say that okay, I can use this model and I can put it in production, and people in hospitals can use this for doctors, can use this for patients to check whether this person is going to get cancer, and the mortality rate is towards the person dying or getting saved. So for those type of use cases, critical use cases, we just cannot go ahead with the accuracy score in itself. We need certain more metrics, and that is the reason we have included these metrics here. And feature importance is something that I have already talked about. Then we also have this dataset explainer. Dataset explainer is nothing but it's just as I mentioned, like a pandas profiling option, and it actually, it's a very good uh, it gives a very good overview about the entire data set, and it gives the data set information, it gives the variable types, it gives the missing values, unique values, and the distinct counts and different statistics. And sometimes it becomes very necessary for a person to analyze or have a pictorial image of a data set in mind when dealing with the experimentation and deciding which model we want to choose. So it also gives the total number of rows and some of the sample data that is there. And the last rows. So this is something which is very important, and this has been incorporated here. And this was related to a classification experiment. I can just go back quickly, and I can actually show some of the metrics related to a regression. So this is a regression experiment. So you can see in the regression experiment, the metric value changes. It is RMSE, the experimentation type is regression, and the recommended model is whatever is the best model for this data set. Then again, I go inside and I see what the three best models which are listed, and the scores are RMSE, mean absolute error, R2, and the fit time. And then I can go and check the explanation for the best model, and it gives me some metric values here also. So again, many a times it might not be necessary that one metric suffices the need for my experimentation to decide whether I go ahead with this model or not. So if that is the case, we are already providing several different metrics so that the user can take an informed decision whether to go ahead with this model or not. So maybe RMSE is not a metric that a user is looking for. He can go for mean squared error. He can go for mean absolute error. He can go for an R2 score. He can go for a Pearson R score. So these are several different values that we are providing to the user so that a user can make an informed decision before going ahead with the model. So again, here also we have the ice plot, and we have the partial dependency plot also. So these are again created for the top two features that contributed to this prediction. Again, if we go and check the feature importance, we'll see that the top two features are, in this case, P class and P arch. So if you go to ice plot, you can see that these ice plots are generated for the top two features, P class and P arch, and how they vary with respect to the output target column, which in this case was fair. And this is again the partial dependency plot for the top two features, P class and P arch, and their uh, variation with respect to the output column, which was fair. Now we also give the model performance plot here. We just give a scatter plot of actual values against the predicted values. And this just gives a visual inspection of, how good my model has performed. And we also give a plot for error distribution. So this just gives us an idea about the distribution of errors in the predictions that we have served. So this is something related to the metrics that we are providing in case of a regression experiment. And again, we have the dataset explainer, which I have already shown in case of classification. And here, this is nothing but this is the same. So with this, I conclude my presentation. If there are any questions, we'd be more than happy to take them.